the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. So today is day 61 and we have crossed the 2 months mark, day 61, and this is lesson 20 in NumPy. So in lesson 19 we saw about normal distribution. When we saw about the normal distribution, we saw that the random dot normal, we saw three things: LOC, scale and size, which is important. We saw the Gaussian curve and we saw how it actually fits and how everything actually fits in the curve. We took an example of the class and the extremely high toppers, the average persons, and the low level persons. Okay, the persons would not score. In today's topic, we'll be seeing about binomial distribution. The binomial distribution is also called as a discrete, so which means it is not continuous. It is called discrete distribution. The binomial distribution, okay, it describes the outcome of binary scenarios, such as when you flip a coin, it is either a heads or a tails. You're not going to get heads and tails together unless and until you do a magic. Okay, but it's either one or the other. Or how do I actually say it? When you actually write an exam, you get only two scenarios, either pass or a fail. There is no in between. If you pass, you pass. If you fail, you fail. Even this also, just like the normal distribution, it has three parameters. N stands for the number of trials, P stands for the probability of occurrence of each trial, size stands for the shape of the returned array. So if you see, like previously we had LOC, the same shape and the size. In this time we have N, number of trials, P as a probability of occurrence, and size as a shape of the returned array. So the discrete distribution is defined as a separate set of events. Okay, the coin toss results is discrete. Okay, this is what I told you. Okay, I gave you some more examples as well, but this is the flipping of the coin. Now let's take an example and let's actually put a binomial distribution here. So here if you see, I have this, I import this random, which is a random. In this case, I have random dot binomial, whereas for the normal I said random dot normal. I give the parameters size, occurrences, probability, and I print the x. So this is what I get. Okay, all right. Now if you want to visualize this, how do I do it? Very nice. So last time we did something. This time you have to import the random, the matplotlib, which is a matplot, mathematical plotting, and the cbon. So these three things you can actually by heart. So these three things are default. You have to do it. So instead of random dot normal, it is random dot binomial, and in this case we need to give the three parameters always for the binomial, whereas for the normal distribution we did not, and we also said histogram as false, but in this case we are telling histogram as true, but that is okay. Okay, that is okay. And you do a C plot, distribution plot, and you actually tend to say show me. Okay, show me the entire thing. Let's actually see. Since we said histogram is true, this is actually coming and this is what it is. All right. Okay, now what is the difference between a normal and a binomial distribution? The main difference, the normal is a continuous, the binomial is a discrete. Okay, so the binomial is a discrete. So that is a main difference. But if there are enough data, the points, it will be quite similar to normal distribution with certain LOC and scale. So in other words, a binomial can be made to normal with lots and lots of data, but not vice versa. All right. Now let's actually take this and let's actually see what this is doing. Now in this case, I take everything the same. Okay, the NumPy, I import the random, the matplot, the cbon. I told you this is needed. So in this case, I'm actually trying to take a normal with all the three parameters and the binomial with all these things. In both the cases, I tell my histogram to be false and the label to be a normal and a binomial. And I say plot my show. Okay, so in this case, you can actually see the difference. So see the difference between how the binomial has actually come close to the normal. The blue line is a normal, okay, the Gaussian curve. Even though in this case the binomial is a discrete, see how closely it has actually come to the normal, and this is exactly what I was actually telling you. With enough data points we can actually make it close to the normal, but not the other way. Alright, I trust this actually makes sense, and I trust you enjoy this graph. Alright, that's all, friend. We also saw about the binomial distribution. If you have any questions, kindly contact me, and I will actually try to help you to the best of my abilities. Like always, I would like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree for allowing me to follow my passion. Till we see next time, take care, cheers, and thank you.